Dru is a fellow and director of building performance, focusing on zero energy buildings, decarb, digital twins, smart cities, and sustainability. I'll let you get up to speed in the program when you're able to log in, but he is the president of IBPSA, which is the International Building Performance Simulation Association, and is active in CIBSE, ASHRAE, and AIA. Dru is our first presenter of the day, who is also in his second round presenting since we've instituted the Not My First Rodeo. So Dru, right before your presentation here, I'd like to present you with this award. Here you are.
That's fabulous.
I'll get this out of your way. I can hold on to that until you're ready.
Thanks. Good afternoon. I'm really excited to be here. This is my second rodeo, but very frustrating to do virtual. I've done so much of it over the last 4 or 5 years that it's just really old. So I'm delighted to actually be in Chicago and to be able to do this. So I'm going to talk a little bit about infrastructure. First, I had to give you a little background on a company I'm with, Bentley Systems. Probably never heard of them. We are a infrastructure engineering software company. So big projects, structural, road, rail, anything of that scale is really kind of the things we do. So I'm a buildings guy, architect and engineer by training, and so I'm kind of an oddball within the company. But anyway, they still somehow trust me to talk about what we're doing. So I'm going to talk about infrastructure modeling, particularly digital twins, in how that works, and show you a little bit of things that we've seen going on. So I always like start talk with talking about energy. Energy equals carbon for the most part. And so I can get energy numbers. I can't get good carbon numbers by country yet. I have been looking for that. But if you look worldwide, buildings are responsible for about 30% of the energy, closer to 40% of the carbon related to that. In the US, it is 40%. It's been growing for many years. Industry's been declining. The contrasts you see, if you look at the third and fourth bars, there's China and Hong Kong. China is about 20% for buildings. 20 years ago, that was 10%. So they've doubled the amount of energy being used in buildings, a huge infrastructure push there. But you still see that industry is still 70% of what they do. That's where the energy is being used and where that's moving. Then you look at the next bar, there's Hong Kong, kind of the complete opposite. Hong Kong is the most extreme in terms of what I've seen. 65% is buildings, and only a few percent at most, maybe 5% for industry. It's a place of business, it's banking, it's other aspects. It's just buildings for the most part, except for their wonderful transportation system. I was there just a month ago. And so you kind of get the contrast between the two for there. But you see it varies kind of depending on whether industry is dominating or whether it's moved toward away from the industry and into more of service. And in the US, you'll see there, we're kind of about typical for what's going on there. So, but if we look at it from different parts, about half residential, half commercial in the US. Before the 2008 downturn, it looked like commercial was going to overtake residential, but that hasn't happened. Everywhere I go, there's still quite a few empty commercial spaces. This is still, 15 years later after that recession. But it's still there. If we wound the clock back to the 60s in the US, industry would be well over half of our energy. Residential and commercial didn't get to be this large until the last 20 years or so. It's where the growth has been in there. Transportation is pretty steady, about a quarter of the energy. The CAFE standards that we have to really make sure that our cars and trucks are efficient really do have what they're doing. I'm looking forward to kind of seeing where this changes as you get EVs that are beginning to make an impact on there. Where I live in Washington, D.C., EVs are now 15 or 20% of the sales. It's just amazing the change in just a few years. It used to be up and down my street, it was all hybrids. Now it's all EVs. So it is kind of interesting to see that change happening there. The city encourages that. You don't pay any tax when you buy an EV in the district, which is worth a few $1,000s. So they are encouraging that as well. Excuse me. Let me get this open so that. Now, this slide is really to show that what we traditionally think of our homes as far as energy use, the heating, water heating, cooling, the appliances, cooking, things like that are still there. But there are a lot of other things going on. In fact, a full quarter of our energy now uses now other uses. It's all the little stuff like this has crept into our lives that are really driving that today. I have almost 25-year-old twins. Their birthday is next week. And when they're home, I wonder why my Wi-Fi is really, really slow. Go on the router, there's 17 devices connected. So that they're all drawing these little bits of power in there. But even computers are now showing up in our residence at 1%. So if we're going to deal with this, we have to deal not just with the top things that is really what our energy codes deal with. We've got to deal with a whole spectrum of energy use in the buildings. Commercial, of course, this is spread across a whole bunch of different building types. For example, refrigeration, only there, you don't think of commercial buildings as refrigeration, but think of warehouses and supermarkets. In supermarkets, refrigeration, freezing and cooling are 50% or more of energy use. So it's a huge part of it. It varies. If it's offices, yeah, it's cooling, lighting, ventilation, heating for that. But most of the other building types will have quite a spread. But again, almost a full third are other uses. Now, you don't see elevators and escalators up there. They're kind of a small number, even in high-rise buildings. You have to remember the average commercial building in the US is 1.2 stories. So it's not the high-rises you see here in Chicago. It's all the strip malls and places like that that really comprise the floor area. We're seeing massive change happening today. You're seeing much more dynamic, much more interactive. People are trying to draw people back into the city. In Washington, D.C., a lot of office buildings are already being converted to apartments because they're empty. People don't go to them like we did just 5 years ago. And really making that more interesting for people to live in, having them come to the city has really been getting there. Multimodal transportation. There are bikes and scooters and stuff littering my neighborhood. I mean, there are 3 different groups doing it, and they just kind of, whenever they run out of power, they just leave them wherever they are. But that sort of change where we now have dedicated bicycle lanes throughout Washington is happening in many places. And I think that's is making them more attractive to live in instead of being so car-based. This is Paris, of course, where the Olympics were a couple months ago and the Paralympics recently. This is a model that was created by flying a small airplane over the city and tens of thousands of photos. Using a process called photogrammetry, then that's converted into a model. And depending on how many photos, you can get incredibly accurate down to a few centimeters, inches. This is the sort of thing you would see from the Google cameras that drive through the city, but you see places where there are not many pictures and you get kind of weird stuff. But what this means is we can now capture an existing building pretty easily in what they're doing. And so that's kind of a cool thing. Photogrammetry has been around for decades, 80 years ago. I have a book written in Serbian from somebody who actually invented photogrammetry in the 20s, I believe, maybe 100 years ago. So it's not anything new, but the power of it and the ability to create a image of Paris in a few, I won't say days, few weeks of computational time is really incredible and possible today. And it's not a single source. You don't have to just take the helicopter or the plane and take pictures. You can do it from the street. You can do it however way you want to do it, whether any different ways. And they can be point clouds as well, or reality mesh, which is what I was just showing you there, 360 images, even obliques that are capturing that data. So it's a way of capturing many pieces there. LiDAR is actually one of the most powerful possibilities of adding this in as well, because LiDAR, you can get down to millimeter accuracy. Here's an example. This is a colleague who's using one of our apps, but it's not really a true pipe. It's just some piece of plastic pushed together. But he sends a bunch of pictures up to the cloud. As long as they're at least 50% overlap, you can get it. And then you get it back. You could take measurements off that. It's that accurate. And so that's kind of one of the key cool things it's been able to do. So in the past, we've been looking at modeling cities and trying to begin to look at their impact. This is a reality mesh model that was created. This is Philadelphia. This was created about 8 years ago. The Pope was coming to Philadelphia, and the city wanted security, because the park you see there, if you're familiar with Rocky, the steps up to the art museum there, that's where he stands, and there's actually a statue of him there. But you see how open this park is leading all the way up, and the Pope was supposed to talk there. But what this allowed them to do is, within this model, but as part of a BIM model, because all these are relatable, is add the signage and the fencing and everything else to show how that would work. So Philadelphia, like Chicago and many others, has been doing building benchmarking for over a decade now, requiring cities to, building owners to submit their energy and water bills in some cases and other information. So this for Philadelphia looks like this. There's a database sitting there. You can get information about energy use. You can do the same thing in Chicago for various buildings. Depending on the city, it's 50,000 square feet or larger. I know some of this has been overtaken by some of the energy performance standard work, but still ongoing there. But if you look at Philly, this is what their database looks like. It's just kind of a flat file that's available online, but it has a lot of information there. Their visualization goes to the point of showing the mapping of it, where the various things are. But what we were able to do is we've got this model of Philly, and now we can start applying the building information on top of it. So what you're seeing here is kind of energy and water with intensity, green up till red, showing the energy intensity of that. Pretty pictures. This was kind of cool when we did it, but but what use is it? And that's where it comes in. Now you can start to use it as a way of identifying outliers, maybe the buildings you want to work on first. You can begin to look at individual buildings, and pull them out. But there's data underlying this. So all that data that was sitting there in the Philly database is now part of this data set. You can sort on property type, you can sort on energy use, and you see the tabs down the side. That's all the data that's associated with that. And I think that's where the power of these reality models begin to be there. So they pick a particular place, and it's a hospital, so it happens to be bright pink, very energy intensive, not surprising. So this is a way to use this going forward. And I'll show you another example where they did this specifically in India for an entire town, not just the larger buildings as they're doing in Philly. So let's talk about the next version of a reality model, a digital twin. And digital twin's not just a building thing. It's industries wide. There's actually a digital twin consortium, and you'll see people, Microsoft and a lot of other places that you wouldn't think digital twins would be useful. But all it is a digital representation, a digital modeling of what's going on in there. The engineering information, it's not a single source. It's federated data sets that you can bring together for many ways, being able to use that. And it's a way to be able to look at visually what's going on in the building. You can generate insights from that. So physical asset data transferred into a model where you can begin to look at insights and decision-making based on information you have for there and come back to interventions. And that it's also live. That's the idea. It's not just a static model. The Philly model is a static model. But the idea is to have something that you can begin to use throughout the life of the building. So it can be, starting from conception, design and engineering on and construction and commissioning, as well as operation and maintenance to be able to use that throughout the entire life cycle. If you're starting with a BIM model, that makes it pretty easy to deal with. So if we look at this from a building digital twin side, you can begin to see how this is captured. This is Cambridge University, that building kind of there in the center is the one we're going to be looking at. This is a West Cambridge campus, so it's not the old stone buildings. This is a new campus that's been built over the last 20, 30 years. And that building there in the middle that we're looking at is the Institute for Manufacturing, one of the partners. So what they've done is take photogrammetry for the outside to get the model. Photogrammetry works great on exteriors. It's really miserable if there's glass, white surfaces. So guess what? Inside of buildings doesn't work very well. But that's where you can use LiDAR. So I'm going to let this play. Yeah. And so now we can begin to, you can zoom in, again, the quality there to look at this. And I can actually make it look like we're going inside. And once I get inside, this is a LiDAR model. And you see the quality of that you can read dials, you can read signs, you can read all sorts of information going on through there. So this is kind of a very powerful tool for doing that. And the LiDAR, again, the accuracy is very, very tight. To the other side, where we are working with a BIM model, this is actually Microsoft's Southeast Asia headquarters in Singapore, and they occupied the 9th through the 14th floor. This is the BIM model. The building's actually constructed at this point, but the idea was to be able to use this as a way to look at data, what's going on. So you see measuring one space, you can see what the temperature's been doing over the last day. These are in Celsius, which is why they look so cold. But also other information, trying to look at sensors, whether a space is occupied. Probably not trying to use that to see whether people are actually bothering to show up. But you can see whether conference rooms and other things like that are occupied throughout the day when the areas are. To another extreme, this is also Singapore, and this is a project showing how you can use the digital twin throughout construction, and then even once it's completed, all the analysis is done, begin to look at, you can look at information. There's solar panels on this and what is the contribution from that in terms of a particular day. You can look at individual building systems. You can go into a particular place, look at the occupancy like we did for the other. This also has the green roofs related to it, and you can use it to have a tour for this particular place. This is a big developer in Singapore that this is one of their headquarter buildings. So that's buildings. We can also do this on the transportation side. In fact, I think the power of that's already being seen. Here's an example. This is using VR goggles. This is what you would see if you were dealing with it. Being able to look at a bridge and inspect it. One of the things that we have, our infrastructure is aging, everybody says, and they point to bridges that are going to fall down. One of the ways to do that is to go out and inspect them. Well, to inspect most bridges, you had to have somebody physically hanging off the bridge, looking at the infrastructure to be able to do that. Now, if I can use a drone to create a digital twin model, I can go further and look at that in more detail. And so that I can actually see what's going on in the comfort of my desk instead of somebody on a rope. So you can begin to have that. And I'll show you in a minute how that also then can be used with AI to kind of push some of that. So here's I believe this is in China, and this is looking at adding an off-ramp on an existing roadway, trying to see how that would fit into the digital twin, being, how that moves. You can add cars, simulating how that is, how that works, and being able to see if that's going to be a problem. Another place in China where the model has been created, the digital twin for that's been created, and can look at individual bridges and see how they're particularly working. So looking at this bridge, we can see whether it's having any issues. This is a cracking defect at a joint, and all the drawings and specs are all really at your fingertips, so it's all there. Load assessment based on any damage that's there, images of that, particularly you can see any of those, and then use some of the AI tools to be able to look and decide whether that's something that needs to be repaired or it's just cosmetic. Another way is to use the digital twin to feed this in. So here we have an existing roadway that's about to get repaved. They bring the model across. Sorry, this runs a little long. And to look at what is actually happening, what's there today versus what do they want to do. So he brings it in, he makes some adjustments in the height of the roadway to take some of these bumps out. And then this is fed directly to the machines that are doing the repaving. So they'll know from the GPS where they need to cut deeper or less to be able to get that. There's also infrastructure, stormwater, water, that's pretty visible. Here, using the VR capabilities, being able to show on a surface what is actually subsurface, so that you're able to look at what's going on, so you can see essentially a diagram on that, and being able to identify where things are without having to dig up the whole sidewalk to be able to find something. So we know from that that's available. Other things, because the digital twin is accurate, we can begin to look at other things. This is Lisbon in Portugal, and showing the impact of a 100-year flood in the historic area. There's just not enough ground cover, places for water to seep in, that in those particular areas, they are looking at real problems. The stormwater system is just not equipped to handle that much information. Other things that could be done, here's Paris again, a little bit newer model than the one I was showing you, but this is showing what happens or what could happen if the Seine floods, which happens a little bit more than they'd actually like. So now you can begin to see there are places up in this top part where the water has not gone above the walls along the river. And they can begin to say, if we raise this a half a meter, then we could begin to prevent flooding in particular areas, so that you have kind of a real-time tool to be able to look at some of that. This is showing as the water is going down, parts of it are beginning to come back out. Also, agent-based simulation, where you simulate the people going on. And it's kind of interesting. There are cultural differences in how people stand together and group and everything, but the models can take that into account. So we can look at airports. This is an example of BIM model that they're looking of a subway station, beginning to look at it with agent-based simulation. They can see they've got a problem there, only 2 turnstiles. They come back in the same model. They've not left the BIM model. And they add in a couple more turnstiles and then resimulate and see what happens with that. And now we've solved the problem. So rather than having to wait till we're done, we can begin to look at that and use the agent-based simulation. These tools have been used for years. Football stadiums throughout the world, whether it's American football or soccer, use these. We need to know how quickly we can get people out of a stadium. They're, tens of thousands of people in there, and being able to do that is really critical. So knowing from a cultural standpoint how people interact, you can also deal with that and know that you can get people out of the stadium in just a few minutes. Other interesting things, this is not tracking traffic per se, this is tracking cell phone signals. So you can watch that this is over the day, that's up till 7 o'clock, 8 o'clock Eastern, and then it'll recycle here. Yeah, so now we're back in the morning. You see it pick up over the East Coast and then move to the West Coast by 9 o'clock out there. So you see where the traffic is and where the volume is, just from cell phone signals, not capturing the signal, but just seeing that there is one. So we take all this together, and now we have an urban digital twin. And so what that is taking the information that we have for existing as well as new. This is a large German engineering company, and they've been on this site for 120 years. And they've now created a digital twin of this to be able to look at all the aspects of it. They can look at noise maps in the neighborhood from traffic and train and seeing other parts of that. They also can actually look at, they had architectural competition for this building, kind of center bottom there, and being able to look at different versions of that, seeing where people, what they look like in context. Now showing some of the sensors that are available here, looking at water flow, and also looking, you can kind of make the ground transparent to begin to look at what's underground, again, for that whole campus. In this case, have been able to tie in at a particular point the inspection that happened, so that there was a visual aspect of that as well. Again, working with a large model. This is Helsinki, Finland. This was something they put together. This is their second generation. They've now got a third generation. I'll show you in a minute. But the people working with this were trying to see what the value might be for the city of Helsinki. It's right at sea level. You see, we're seeing flooding here if we get any aspect of that, and that is the historic core of the city. But this is their third generation model. This is the 26 square kilometers of kind of the historic core of that, and being able to look at it. Now they've used deep learning, machine learning in this as they're creating the model to try to automatically get what each of the elements are. Is it a roof, is it a facade, et cetera? What are the bits and pieces related to that? And so they're being able to start to look at that in more detail. That was a good first start. But they've already thought about what can we do with this digital twin? And this is from their website. And so carbon neutral, smart, business, marketing, tourism, city events, planning, the whole range of things. And if you see a red dot, they've not really done anything with the model to do that. But you can see the green dots mean that they're actually already beginning to use that in the city as they move forward. So the city that kind of took it a bit further, this is Ahmedabad, Southwest India in Gujarat, if you know your geography. And this is actually a kind of a test. This is about a 1 by 2 kilometer piece where they flew drones, collected the data, and began to look at the information they collected. Mixing that with land use, whether it's, this case, just showing the residential, commercial, industrial areas. The center part where it looks the most dense and different, that's the historic part of the city. But they're able to take that then and start to look at other pieces of it and see what's going on. These, but having this, these are extrusions, these aren't actually the model that you saw earlier. They began, you can look at, this is building type again, but now begin to look at water consumption by building. Of course, big building is going to have higher consumption, but also looking at energy and seeing that. They created an Energy Plus model for every single building in the city for this. which was pretty amazing. Partly they want to look at what are the aspects of that can help them identify retrofit opportunities within the city. ECBC is their National Energy Code, and being able to look at that. So you can see which ones, baseline scenario where we are today, but then where we could be if we started doing some retrofits. Pretty powerful piece. This, I talked about Helsinki being 26 square kilometers. This is 240 square kilometers. It's a huge city. We're continuing to work with them today on this. We're looking at some new opportunities, looking at resilience, particularly as they're expected to be kind of in the path of some of the extreme temperatures that have been happening this year and past few as well. So they're looking a UN project to work on that. This is the only countrywide digital twin I'm aware of, but it's Singapore. It's an island or a series of islands. So it's really kind of a key thing there. You can look at it. We looked at master plan. We looked at energy intensity. Now we're looking at solar potential throughout the city, building performance where the big energy users, I don't think these are area normalized. Water systems there. Also looking at demand, transportation systems. So lots of possibilities there. So Singapore is using this. This is an open digital twin that they're using that, trying to begin to look at how they can use that to really shape the city, the country as they want to go forward with it. So why do we need digital twins? Well, the UN Sustainable Development Goals across the bottom, where they impact is pretty much across the board. So urban and real estate development, asset management, environmental intelligence, climate monitoring, transportation and mobility, adapting the energy production. So there we have the renewables, public safety and security. And actually, I think that's one of the things we're seeing early is the use of the digital twin, if it's just the transportation side of things, where sensors and cameras are finding traffic jams, they can begin to direct people other directions or change lights at real time to be able to deal with that. So that's kind of one of the interesting things. So it begins to empower people to do more. We can simulate and monitor, make adjustments, immersive visualization. It's a lot easier to explain to somebody who doesn't know how to read drawings and plans if you show them visually within the space they're working in. Analytics can be applied, as you've seen, directly in the model. AI, machine learning, all the different tools that are emerging there are really becoming quite powerful to be able to do that. And I think the key thing is decision support, so that if I need to make a decision, I can do various alternatives within the model to be able to look at seeing there. Cost and time savings is also a big part of that, and sustainability. So we're trying to look at a bunch of different things, which together is a lot. It's just very difficult to be able to look at everything that we're working on there. So, from urban planning, we looked at that, sustainability, planning coordination, efficiency, citizen engagement. I think that's where we're going to see a lot of this early. Housing affordability, urban renewal, accessibility. We worked with a town in Iowa, and they're required by ADA to have curb cuts throughout the city, and they had no idea what they had. They decided it would be easier just to make a twin of the city and found out where they could actually plan and work with that. So there was public space improvements, kind of a big thing happening globally. Asset management, construction workflows, all various things here. So digital twins really make it easier to understand our buildings, our communities, how they interact with the environment. It's federated data. It's not one source. It's not one platform. There are multiple out there. so that you're not tied to any one vendor. That's kind of one of the key things. But photos, point cloud, mesh, all the things I've been showing you here are all possible to put in the same model. And that's kind of one of the power of the digital twins. As you get new buildings in place and you have BIM models, you can place them right in there, replace that. So it's kind of a really powerful means of getting a model what you're trying to work with. It is a holistic view of what's going on, so you can look at risk, resilience, and sustainability at individual building, which is, I think, where a lot of the buildings community works, unfortunately. But now we can start to look at community, city scale, even whole country scale, at least starting with Singapore. And it's not a single discipline. Engineering, civil, mechanical, all the electrical, all that infrastructure, as well as the building and the urban planning. One of the things that's happening that makes a lot of this more powerful is 5G deploying, being able to get real-time feedback from and to sensors and being able to look at that. So I think that makes it a powerful tool for policymakers trying to understand. I think, I may have this wrong, but City of London, if you're there are at least 5 cameras on you at any time in the central core. So they know where they're having problems pretty quickly. And the same happens with traffic as well, so they can be able to do that. With 5G, they know that quickly. There's no lag time. 4G, not so much. And so what that comes down to is anything that is measured locally can be connected together in the future. Our smart buildings with the IoT portion lead to smart cities, and then we have that interconnectedness on a platform called a digital twin. So, other thing, I'm a building simulation guy. That's where I got my start, where I've been doing it for a few years. There's a data set that's got about 3,000 locations in the US. Climate.one building, if you're interested, all the data are free. And this is not part of my Bentley role, this is my free time role. We just published a data set with data through 2023 up there. So you have to the last year data availability for that if you're interested. So with that, I'll take any questions.
Thank you, Dru. Thank you, Dru. This work? There we go. Thank you so much. I think if my education at Energy Plus was anything like this, I would have stuck with energy modeling. That was really cool. John, you have a question.
Would this modeling be at all useful for the utilities to model their distribution systems?
Oh, yeah.
The whole issue of renewable energy storage and resilience system.
We sponsor, my company sponsors a few PhD students. One of them right now is working on a model of the UK electrical transmission distribution system and how renewables would impact that. So it's very localized. And so he's spending time on that. We just started a collaboration with the University of Glasgow. They are going to create a digital twin of Scottish Power's entire system. And so the utilities have some set of models, but I don't think they have them to the extent, the detail that's possible here. With a lot of what we're seeing here is the ability to actually go out and create a digital twin of the substation. They may not know what they've got at the substation. You fly a drone around for a few minutes and come back, you can tell, they can see what transformers they have and what's connected. So I think utilities have a huge, huge potential here.
Dru, that was truly amazing. But my question is, you're all over the place. How is your work generally funded?
A lot of these are funded other projects. Bentley does do some work specifically with the universities. I'm in the sustainability and education group, and we've worked with different campuses to try to, as a platform for teaching whatever it's civil or structural or buildings, whatever the aspect is. But for the most part, what you're seeing here are funded by cities and other aspects. Singapore, that work was funded by the government specifically, that they saw it was an opportunity to really understand the whole of the country and in a way that they could look at it real time.
Amir? Well, thanks, Drew, as always. Lovely presentations. Kind of similar question on funding maybe, but I couldn't help but notice that the examples you showed mostly are progressive cities or countries who see the value, right? This is quite a no-brainer.
Yeah.
I'm curious, in your experience, why aren't like everybody doing it? Like if they're seeing it, I wonder if there's elements of maintaining these databases that, or maybe the lack of expertise on the, it's called owner, operator, or city planner side of it. Any comments along those lines I'm curious about?
Well, I think there's costs associated with it, but one of the beauties of this, and I didn't really show that aspect of it, is the existing databases can remain intact and data be drawn from them. One of the issues with IoT and smart anything is security and being able to control who has access to the data. So for the Singapore digital twin, there are various levels. And if you don't have access, you don't get access to that. Not everybody needs to know the energy use of their neighbor's house. And there are models that get to that detail for that. So I think that's kind of we're not quite sure what to do with making sure that security is there for that. Privacy, big, yeah.
Drew, quick question on, I'm thinking of this because our next speaker is going to be talking about AI, but are there restrictions on getting data sets in certain places other than with privacy concerns of taking the pictures and getting imagery of people and homes and things of that nature?
Well, if you wander through Google Maps and look at it, you'll see obscured people. And I think that same thing is true here. So trying to get something that's got the security aspects and deals with that in a way that people have maintained their privacy is really still pretty critical. The data sets, as you say, who has access is a key thing, and I think a lot of groups are struggling with that as well. Even with my own company, we use AI tools through that, but we have a tight restriction that we can't use any external tools. And I have an intern working for me right now. He's using a particular AI tool, being able to look at it and trying to collect information about user projects that we've got. And he's been able to find information that nobody else has been able to because the tools are powerful. But that's because we have access to the data.
You had shown examples of stuff like either finding utilities underground or inspecting bridges. Has anyone fully adopted that as being the primary practice, or are they still just doing hands-on inspections?
There's a lot of that, but there have been companies that already, there's a company out of Pittsburgh that's been doing drone-based surveys for at least the last 5 years. And I think that's becoming more common, particularly it's costly to get a body out there. But if I got a drone operator spending 2 hours capturing a bridge, that's a lot cheaper than getting somebody in a rig. And I think that's so. And with the concern about how behind we are on maintenance, people are beginning to do it more.
We have time for just a couple more questions. If there's any remaining thoughts.
We've had a handful of issues at Cyclone with drones getting destroyed. Is that something that you guys encounter when you're trying to collect data? And has there been any improvements in that regard?
Sorry, I didn't catch the whole thing.
Sure. At Cyclone, we've had issues with drones encountering serious wind or weather and getting
Yeah.
destroyed. Is that an issue that you guys encounter when trying to collect data?
It's always an issue if you got a drone. I have my own little drone that's below the radar of what FAA requires, and I regularly have trouble. It drives into trees when I don't want it to. So yeah, big drones you do. Even as powerful as some of these are, they are still restricted by what you can do with wind elements.
So part of this thing is you've got these large data sets, and you'd mentioned about one city that had created all of these calibrated Energy Plus models.
Yeah.
For anyone who's calibrating from a large data set that's mostly utility end data, is there another data set that's feeding into that so that the individual aspects of the building are more or less correct to what's actually there, and we're not overestimating infiltration
Yeah.
instead of under insulation or something like that?
I thought I had another video in here that would allow me to explain that for Ahmedabad, which is the city in India. They actually use the AI ML to be able to determine window areas and things of each of the buildings and try to strip back the trees, because there are a lot of trees at ground. But they were tapping into the utility databases and the business databases, so they knew in each building what was residence, what may have had some sort of business associated with it. So it was taking that together. There's a similar data set, City of London, where they basically pulled together all the publicly available data sets. They know in each building by floor what the occupancy is, whether it's a store or a business or a house, and being able to do that and merging that with the utility data as well. So unless you can do that to do some calibration, yeah, it's just a model of a box. So.
Well, thank you so much, Drew. Really appreciate the presentation.